Welcome back to section 7.2. Today we're going to be talking about solving again. So once again, don't forget the log base b of b to the x equals x, and b raised to the log base b of x equals x. The inverse of log is exponential. The inverse of exponential is log. So since we're undoing the exponential, we're going to use log, and the base of the exponential is 8. So we're going to take the log base 8 of both sides. So log base 8 of 8 to the x, log base 8 of 20. On the left-hand side, they undo each other. So we're left with x equals, and the exact answer is the log base 8 of 20. Now to calculate that, you can use your change of base, log of 20 divided by the log of 8. So when you type that in, you're going to get about 1.441 on your calculators. And if you check, you can do 8 to the 1.441, and you're going to get a number really close to 20. It's not going to be exact because we've rounded this value. For problem number 14, to undo the exponential, we're going to take the log, and in this case, log base 7 of 7 to the 3x equals the log base 7 of 18. On the left-hand side, the log base 7 of 7 cancel each other out, so we're left with 3x equals log base 7 of 18. To isolate the x, divide both sides by 3. Now to calculate this, a little bit trickier. The exact answer is the log base 7 of 18 over 3. That's the exact. Now to calculate that, you'd want to use your change of base. You would do log of 18 divided by the log of 7, hit enter, and then divide that whole thing by 3. And you're going to get a value of x is about 0.495. And you can always check by doing 7 raised to the 3 times 0.495, and you're going to get an answer very close to 18. For number 15, you want to isolate the exponential first. Start by dividing both sides by 3. 11 raised to the 5x plus 2 equals 33. Now you want to undo the exponential using the log base 11, because that's the base of the exponential, of 11 to the 5x plus 2 equals the log base 11 of 33. So we end up with, on the left-hand side, the log base 11 of 11 cancel. 5x plus 2 equals the log base 11 of 33. Then you're subtracting 2 from both sides, so 5x equals the log base 11 of 33 minus 2. Divide both sides by 5, so x equals, now the exact is the log base 11 of 33 minus 2, all divided by 5. Now, once again, calculating this is a little bit tricky. What you would do, log of 33 divided by the log of 11. Hit enter, then you would just subtract 2, hit enter, and then divide that whole answer by 5. And you're going to get x equals negative 0.108. And then if you substitute back in, you'll see that it does give you an answer very close to 99. For a problem like number 6, let's isolate. So we're going to subtract 1 from both sides. 6 raised to the power of 4x, 1/3 times 6 to the 4x equals 5. Get rid of the fraction, multiply both sides by 3. 6 to the 4x equals 15. Now to undo that exponential, Log. Log base 6 of 6 to the 4x equals the log base 6 of 15. Left-hand side, this log base 6 of 6 cancel. 4x equals the log base 6 of 15. Divide both sides by 4. And now the exact answer is the log base 6 of 15 all divided by 4. So to calculate that, you would do the log of 15 divided by the log of 6, hit enter, and then divide that whole thing by 4. So you're going to get an answer of about 0.378. All right, and that is solving logs and exponentials. All right, thank you for your time, and I will see you in the next video.